Hello everyone, welcome to the next lecture. In this lecture, we shall see problems related to compound interest and understand the power of compounding. Let us check the concepts and formula. Compound interest. It is the interest calculated on the initial principal and also on the accumulated interest of the previous periods. This means that interest is added to the principal amount and in subsequent periods, interest is earned on this new total. That is, here the interest is added to the principal and then for the new total, we will be calculating the compound interest. The formula for total amount when the interest is compounded annually is given as A is equal to P into 1 plus R by 100 power n, where A is the amount, P is the principal, R is the rate of interest and n is the time period in years usually, and C is the compound interest. So if you see, we can rewrite this R by 100 as lowercase r, where R is the rate of interest in decimal form. So the amount is given by P into 1 plus R power n, and the compound interest is equal to amount minus principal. Now we shall see the compound interest formula calculated for different time periods. We know if it is compounded annually, then the total amount will be equal to principal into 1 plus R power n. If it is compounded half yearly, then the total amount will be equal to 1 plus R by 2 power 2n. That is, we have to divide the rate of interest by 2 and multiply the number of years by 2. If it is compounded quarterly, then we have to divide the rate of interest by 4 and multiply the number of years by 4. In general, if it is compounded x times an year, then the amount will be equal to P into 1 plus R by x power xn. Here, xn refers to total number of terms in the time period. For example, if the compound interest is calculated for every 4 months, compound interest compounded every 4 months and the total time period be 2 years, then we can say x will be equal to 12 by 4, that is number of terms in 1 year, which is equal to 3 times, and xn will be equal to 3 into 2, which is equal to 6. So in the power term, you have to use 6 and rate of interest you have to divide by 3. So this is the formula for calculating the compound interest if it is compounded x times an year. Next we shall see some special cases. When the interest is compounded annually but the time is in fraction, for example, if it is 4 3 by 5 years, then the total amount will be equal to P into 1 plus R power 4 into 1 plus 3R by 5. That is, the fraction term will be coming separately in addition to the regular term. Next, when rates are different for different years, for example, if it is R1 percentage, R2 percentage and R3 percentage for the first, second and third year respectively, then the total amount is given by P into 1 plus R1 into 1 plus R2 into 1 plus R3. So this is the formula for total amount if the rate of interest are different for different years. Okay, before we proceed to solve the problems, I would like to quickly give the effect of compound interest compared to simple interest. Let me open a spreadsheet and then show the difference. Let us assume a sum of say 10,000 units and let the rate of interest be 10% and the number of years be 20 years. Okay. So let me plot the simple interest versus compound interest for the same rate of interest and number of years. This is amount through simple interest and this will be amount through compound interest. Let me calculate for some 20 years. Okay. So the amount for simple interest is given by principal, that is this value, let us fix it, plus PNR by 100, that is the simple interest. P into N into R divided by 100. So the N we shall consider the corresponding year from this one. Okay. Now we shall fix the top terms and let the number of years vary. So in the first year it will be 11,000, the second year it will be 12,000 and it goes on till 20 years. Finally it will be 30,000. This is the amount after 20 years. Let us see what will happen in case of compound interest. Compound interest will be equal to principal into 1 plus rate of interest by 100 power n. So the top terms fixed here and the number of years keep varying. So in the first year, simple interest and compound interest will be same. As we increase, we can see here the compound interest is more than double after 20 years for the same time period. Let me change the format. Now we shall see the comparison of simple interest and compound interest with respect to number of years. Let me plot it. Okay. Here we can see the simple interest is linearly varying, or the amount due to simple interest is linearly varying, whereas in compound interest it is non-linearly varying. We can see the difference as the time period grows. This is for 10%. If I am increasing for some 15%, you can see the difference is much higher. So it is even more than 4 times. So this shows the power of compounding. So as you keep compounding over number of years, then the total amount will be increasing significantly higher than the simple interest. Okay, let me change for 20% and then see. Okay, so the difference is vast. So this is the power of compounding. Okay, we shall solve few problems in the next lecture. Thanks for watching. I will see you in the next video.